For this video, I'm going to do things a little bit differently because this is much longer, a lot more steps to it. So what I'm going to do is just walk you through it rather than actually doing each of the steps. By now you should be able to go ahead and create a problem statement. So let's take a look at what we have. We have the vet clinic that we've been using throughout the class. But this vet clinic is different. It also does rabbits, horses and dogs and cats and gerbils. But that's all it does, and that's the only ones that it looks at. So what we have to do is they want to find out the human year equivalent. We've done that a couple of times already, so you know the math on it. So let's go ahead and take a look at the problem statement. So the first thing is they want to know human years, and we know from before that if we take the pet age and then we multiply it by whatever the animal year multiplier is, then it'll give us our human years. And then, so we move our output up here, we figure out the thing, and now we know that there's two things we need to know. One is pet age, and that's something people have to tell us. So that goes up into input. And then animal years is going to be a generic, whatever it happens to be, and it could be any one of 5 different numbers. So then we go and take a look at our low-hanging fruit. If we go up, we see that each one has a multiplier, and if we took a look at the problem statement, they all have numbers. So we take those numbers and document them here in our problem statement in our assumptions area. So these are our assumptions, that 7, 6, 10, 4, and 20. Those are the numbers we're going to use depending on whether it's a cat, dog, rabbit, horse, or gerbil. So then we go ahead and start doing that. We say, well, if the type of animal is a cat, then we're going to take the cat years, which is 7, and assign that to animal years. So that down here we can multiply it by, say, the pet age is 10, then the human years is 70. But where we're going to get the animal, the type animal from, and of course that also has to be provided to us, so that is also going to be input. And notice I don't like this years alive here. That probably should not be there. Well, of course, I can't delete it because it's on the web page. But you might not see this when you look at the notes. But we do want to put cat, dog, rabbit, horse, gerbil here in parentheses, and I do that so that I know that this is what I'm going to be testing down below. And I copy and paste it down so that I'm very accurate in doing that. So this is a typical if, else if, else if. So if it's a cat years, then we use else to say that, well, if it's not a cat, let's see if it's a dog, and then we put the dog years in. Well, if it's not a dog, which is else, then let's see if it's a rabbit. If it's not a rabbit, let's see if it's a horse, and if it's not a horse, let's see if it's a gerbil. All right, we want to make a test for every single one. We don't want to assume that if it's not a horse, it's automatically a gerbil, because if they make an error and type in, say, rabbit with 3 B's by mistake, we don't want to tell them it's the age of the animal is in gerbil years, which would shock them if they had a horse or a rabbit even, because the gerbil does not live very long. All right, so then we take that problem statement and we copy and paste it down into the human algorithm. So here is our problem statement from up above. Copy and paste it into our human algorithm. We simply get rid of all the spaces, add input in front of input and output in front of output. Other than that, everything is the same as we've done ever since we started. All right, so the next step after that is our flowchart. So let's take a look at that. Flowchart works the same as it has for all the problems up to now. We start out with our assumptions. So all our constants will be declared up here. Then we'll ask them 2 questions. We want to make sure that when we ask them the type of animal, that we don't just have it blank. We say in quotes, cat, dog, horse, gerbil, or rabbit. Okay, and we do that. We want to make sure that we tell them what we're looking for. We just can't say what kind of animal do you have, because, well, they might say that they have a kitten, which is really a cat, or they might say they have a gelding, or or a hare. We don't want them to do that. We want to, oh, well, I have a hare, but really it's a rabbit, so let's go ahead and type that in. You always want to give them the options that they are going to be picking from. Okay, once we do that, then we do our if, else, if. So if it's a dog, then we put dog years and animal years. And then we do it immediately another decision. Let me move this down a little bit. A little more room so we can see. So if it's not a dog, then it's a cat. Then let's see if it's a cat. If it's a cat, then we do that. If it's not a cat, then we're going to test to see if it's a rabbit. If it's a rabbit, we put the rabbit years in. Else, if it's a horse, then we do the horse. Else, if it's a gerbil, then we do a gerbil. Now, the last thing we need to do is, and this is something new for this section, and this is called error checking and error trapping. If a person made a mistake by typing in a capital G for gerbil, or misspelled gerbil, maybe B-A-L instead of B-I-L, we don't want it to be processed as anything. We want to let them know that a mistake happened. So we do this type of output. We say, your animal doesn't match. Well, I don't even like your animal. Let's change that. I like you typed, so they know they made the mistake. You typed this as the animal. And I'll put in here, it doesn't match cat, dog, rabbit, horse, or gerbil. So let's see how that works. I'll go in here and I will run the program slowly. Come on. And I put in here cat with quotes. And now it's going to check that, and it's going to trap that error. And then I'm going to say, well, it's 10 years. See, it says, you typed cat, but it doesn't match cat, dog, and I can see where my error is. Oh, okay, I needed to type C-A-T, not K-A-T. You always want to let them know what they typed and what they should have typed so they can compare it and not make the same error over and over again. And the age is O for O. Now, there's another thing we can do here, and that is, gee, why did we have to ask them pet age if they made a mistake up here? So really, pet age shouldn't be here before we make that determination if they've made an error. We should actually move it down here. So now if they make an error and they type in cat, it says, hey, you didn't match, and then now it's going to ask my pet age. Well, that's not right either. Why is it asking that question? An error has occurred. We can't process this thing. So let's go ahead and stop it and fix that too. What we want to say is that if they made that error, we don't want it to do this at all. We want it to skip it. So how can we make it skip this if an error has occurred? So what we use is something called an error flag. If it comes down here, what I'm going to do is I'm going to make an assignment. Now, I'm going to call it error flag, but that doesn't mean anything. It's just to except for someone coming after me and looking at my code and they'll go, oh, it's an error flag. He's using that to flag an error. So if I say the error flag is 1, if they make an error, I can test for that down here. And I can say, well, if error flag equals 1, that means an error has occurred. And what I want to do is actually another output. And I'm going to copy this one because it's the exact same one. And you might be thinking, well, why would we put the same output a second time? Well, when we code this, we want this to be a document write, that other one to be an alert. Well, what about all this other stuff here? Well, we only want to do this if no error has occurred. So if error flag stays 0. So if an error has occurred, it'll just do this. If an error doesn't occur, then it'll do that. So let's go ahead and see how this works now. So first I'll do it right, cat. And then it's 10. And the age is 0 of 0. So that's a problem. We'll have to fix that. Okay, and the other thing is, let's do it wrong, cat. And now it says, hey, you made a mistake. And then the program gives me the second error message and then just quits. So I have to figure out what's wrong with this right here. Why is human years? Okay, the app. This should be human years. Probably see if we made this mistake here. So we'll copy this. Someone didn't copy and paste. I'm using an old one, so this doesn't count. All right, so let's see if this fixes our problem. All right, so it's cat, and it's 10. Okay, so I'm doing this on purpose. So pet years is coming out as the age. Oh, I see. Age of pet type is. So what is the issue here? So first thing is it's type animal, not pet type. What happens is over time I change the names of these things and then I break things. But it's a good learning opportunity. All right, so this should be not pet type, it should be animal type. And then human years is not working either. So let's see what we have wrong here. So we have pet age times animal years. That's animal years, but look what happened to cat. Cat just says animal. What happened there? All right, so copying and pasting, and who knows how this, like I said, this is an old example of mine, so I might have been changing it just to play around with it a little bit. So there it is, and then I went ahead and I showed you how to debug your code. You start from the bottom and you work your way up. So now when we say cat, and we say 10 years, now it says the age of the cat is 70, everything's working perfect. And then if we say cat, then it tells me I made an error. It lets me know that again, and then it's done. All right, so we're ready to go ahead and code this now, and that will be in the next video.